Hello everyone, let's talk about these three confusing terms because a lot of people use them casually, even some earth scientists, but they don't really know what they are. Okay, let's deal with this first. Let's deal with the bottom one, molten rock. What does that mean? Well, this is not the kind of term you can pull the roots and form a definition. That happens from time to time. You just because two words are together doesn't mean, like, molten rock does not mean rock that is molten. That's not what that means. Molten rock, by definition, a rock has to be solid. By definition. Not a liquid, not solidus, not liquidus, not somewhere between. It has to be solid because they're made of aggregates of one or more minerals or mineraloids or mineral matter, which also have to be solids. Okay? So molten rock just means rock that has been melted. It does not mean rock that is in liquid form. Okay? So I hope that clears up. There's a term I like to use instead of this. I just like to say melt. All right? Because that does not imply that you can have a liquid rock. It's just melt. And this seems to be taking a little bit, coming to the forefront, if you will. I use it, others use it. Why? Because these two are also confusing. Magma is melt underground, okay? That's what it is. Lava is melt at the surface. And you may be like, well, Steve, why is that confusing? Well, I mean, it's fine if you're... Cat. Come on, buddy. Get down, Black. Come on. It's fine for, like, active volcanoes. I see the point of differentiating with that. But in the rock record, going back millions, billions of years, these terms are meaningless. Okay? Because you're just dealing with solid rock at that point. And I guess this term isn't as bad as this one. And you may be like, but why? Why is lava bad? Because lava has two definitions. This is where it gets confusing. Lava is not only melt at the surface, it's the rock that solidifies from that melt. So it is actual rock too. The term is used interchangeably. And that gets confusing. Like, you may have heard this before. If I talk about the mid-continent rift, I will talk about lava flows. Those flows have been dead or have been solid for 1 billion years. Okay? At least 1 billion. So people do that all the time. They'll even name beds lava, like, the Portage Lake lava, something like that. But these are all rocks. These are not melts at the surface, okay? So instead of using, this is what I do to try to mitigate this whole thing. I do use the term molten rock from time to time when I'm talking about rock that I know was solid and has been heated enough to melt. I will use that term, but I try to avoid it. I try to use the term melt for all molten earth materials. We'll just say that, earth materials. Okay? Doesn't matter if they're on surface, doesn't matter if they're underground. I only use lava as the solidified rock. Okay? And you may be like, why the confusion? Because a long time ago, 19th, early 20th centuries, before we really understood, because you got to remember, during that time, we still didn't know if granite was a metamorphic or an igneous rock or a combination. Okay? So the terms lava and magma had some relevance. And as time went on, and we learned that almost all, if not all, granites are actually solidified melts, okay? And we know by their texture and their crystal size that they had to have formed underground, so you don't need to say it, all right? If you're talking about, you know, it is, you can just say its melt was. You don't have to say the magma was, all right? It's just use the word melt, okay? So now we know a lot more about how rocks form. And this came to have two definitions because even in the 19th century and 18th century, we would observe this molten rock coming upon the surface and solidifying. So the term just kind of came about to be both. You had a lot of different schools of thought in the 19th and 18th centuries. And they really weren't theories because that term really hadn't developed as it does in modern usage, especially in science. There are more schools of thought. That's like what uniformitarianism is. It's not a theory. It doesn't predict anything, okay? It's a school of thought. But you also had Neptunism and Plutonism. The Plutonism people thought igneous rocks, if not all rocks, formed from a melt. Oh, he's back. The Neptunists, believe it or not, thought most, if not all rocks, because they would see sediment settle out of water, you know, in streams and things like that, and streams moving it. So they assumed all rocks solidified from water. Now we know that both happen. You may be like, what rocks solidify out of water, Steve? Well, carbonates can. They don't have to be organic. Carbonates can solidify out of seawater. So gypsums, you know, evaporites, stuff like that. Plutonism, well, igneous rocks. We also had about, you know, you're taught igneous, metamorphic, and sedimentary now, right? Those three. It wasn't always that way. There were about half a dozen, if not 2 dozen, terms, all implying origin. So that's how this mess began. All right. And it's just as time went on, we kind of settled on stuff. But there's still confusions. But anyway, I hope that clears it up. If you have any questions or comments, please leave them below, and I hope you learned something.